Good morning, learners and viewers. Welcome to the session of Operations Management MMPO 003. Today, we will be continuing with Unit 8, that is Inventory Planning and Control. First of all, the thing is that what this term inventory means. This pertains to the raw materials, work in process, and finished products of the business. Inventory management is a critical function that determines the health of the organization. Inventory is a stock of items an organization keeps, meeting internal and external customers' demand. Inventory items are divided into two categories, that is, specific inventory items and dependent demand inventory items. The first is determined by the item's usage history and quantitative. In contrast, the latter is determined by the manufacturing plans of the final products, in which the items under consideration is a component. As a result, the independent specified inventory items are founded on the replenishment philosophy, whereas the dependent demand inventory items are founded on a requirements philosophy. What is the concept of inventory? What does all inventory means? What are the different terminology what we are going to use during inventory concepts? So we will start with ordering cost. Costs related to ordering raw material for production processes, advertisement, consumption of stationery and postages, telephone charges, inspection fees are examples of ordering costs. Secondly comes setup cost. The cost of setting up machinery before starting production, that is the initial. Setup cost is generally assumed to be independent of the quantity ordered or produced. Then comes carrying or holding cost. The carrying cost is coupled with carrying or holding inventory. This cost generally includes the costs such as rent of the space, used for storage, interest on money locked up, insurance of stored equipment, production, taxes, depreciation of equipments, etc. Then comes back order, an order not fulfilled due to lack of readily accessible stock. The product may not be available in the firm's current stock, but may still be in creation, or the firm may require further production. Then comes shortage or stock out cost. The penalty cost for running out stock, that is when an item cannot be supplied to the customer's demand, is known as shortage cost. Lead time, the time interval between placing an order and receiving the ordered goods. In another way, it is elapsed time between placing the order and having the goods in stock. What are the different types of inventories? Based on their nature and purpose, inventories are broadly classified as pipeline inventory. Pipeline inventory is all the items in transit between the different locations of a supply chain. The inventory may be on its way to a factory from a large distributor when it will turn into finished goods inventory. Buffer inventory. Inventory maintained to meet the average demand during the lead time and emergencies, transportation delay, or surges in demand. Then comes your anticipation inventory. Additional finished product or raw materials bought by an organization. Decoupling inventory. The stock is maintained to reduce the interdependence of various stages of the production system. The next concept is what is inventory? Inventory is considered as since most of the cash is tied to the inventory. This discourages the organization from investing in other business areas. The adverse effect of excess inventory can disrupt cash flow and hampers business growth. Companies do product planning to meet demand while reducing expenses. It involves forecasting demand and making the right decisions about how much stock and when to order. The benefits of inventory planning are: it reduces the total cost of inventory, it optimizes inventory allocation routes, always have the necessary products to meet customer needs to avoid overstocked products, and increases customer satisfaction through sales protection. What are the advantages of inventory planning and control? Inventory planning and control are essential tasks of any organization. Inventory planning insists on developing estimates to determine how much inventory should be kept, satisfying customers' need. The main advantage of inventory planning includes increased transparency, smooth cash flows, increased profit, enhanced customer satisfaction, etc. Inventory control also has many benefits, including warehouse cost reduction, waste minimization, boosting efficiency, increasing internal communication, and raising the quality standards of the organization. How to control the inventory? Inventory is necessary to give operating flexibility to the system. The stock can be divided into three categories, that is, finished commodities, in process material, and raw resources. Inventories eliminate reliance between factories and suppliers. Work in progress inventories eliminate machine dependency in a product line. Stock billing completed products remove dependency between the factory and its customer or the market. Inventory decisions. Inventory control decides what and how many items will be kept in stock. It also determines the time and quantity of various items to be produced. Inventory managers often make the following two fundamental decisions: how much to order and when should the order be placed, because this all includes money in the form of cash and resources. What is the concept of EOQ? EOQ stands for economic order quantity. The inventory problems in which demand is assumed to be fixed and wholly predetermined are usually called economic order quantity or lot size problems. If the purchase quantity is less, the order cost will be higher. The ordering cost decreases as the purchase amount increases, the carrying cost will increase. The total cost curve is shown in the figure. It is equal to the sum of ordering cost and the carrying costs. It is evident from the above that the minimum total cost occurs when the ordering cost and inventory costs are equal. So we have to remember that ordering cost equal. Then comes continuous inventory system. A continuous inventory system is also known as fixed order quantity system. A continual record of the inventory level for every item maintained. Whenever on hand decreases to a predetermined level, it is referred to as reorder point. A new order is placed to replenish the inventory stock. The order that is placed is for a fixed amount, that minimizes the total inventory cost. A positive feature of a continuous inventory system is that the inventory is continuously monitored, which enables the management to know the inventory status always. Periodic inventory systems. The periodic inventory system is also known as fixed time period system. In this system, the inventory on hand is counted at specific interval of time. It can be a week or it can be at the end of each month. After the inventory in stock is determined, an order is placed for an amount that will bring the inventory back to the desired level. The inventory level is not monitored at all during the time interval orders. So it is the advantage of less acquired record keeping. Inventory challenges. Inconsistent tracking. Using physical tracking of inventory techniques spanning many application and sheets is lengthy, unnecessary, and prone to mistakes. Some of it for a centralized stock monitoring system with financial functionalities, warehouse efficiency, receipt and collection, packaging, and transportation are all labor incentives procedures in the administration of inventory systems. At the storage, the aim is to manage all these activities as efficiently as feasible or possible. Inaccurate data. One must precisely know what stock quantity is available at any given time. Changing demand. Demand from consumers is continuously maintaining excessive, obsolete stock that one cannot market, whereas maintaining inadequate stock may result in an inability to meet clients' demands. Order methods to store vital supplies and technologies for creating and executing a stock plan can assist in compensating for demand swings. Limited visibility. If goods at the storage facility are challenging to recognize or identify, it results in insufficient, erroneous, or postponed deliveries. Acquiring and locating the current or the correct inventory is critical to effective storage operations and pleasant client interactions. What are the problems which are faced during inventory planning or inventory control? Inventory management models enhances the business by keeping up the perfect measure of inventory while lessening costs. Deterministic inventory problem with no storage shortages. Problem of economic replacement, that's production. Deterministic inventory problems with shortages. Infinite demand for multiple products and models with uncertain demand. We'll see. First of all, we will start with deterministic inventory problems with no shortages. Orders of the same quantity are placed regularly in this inventory approach. The goods purchased are immediately replenished and steadily depleted. The purchasing price per unit remains constant regardless of transaction size. Whatever may be the order size, the cost will remain the same. Now let us assume that D denotes the annual requirement in units. The ordering cost is C0. CC denotes the carrying cost per unit per year. P is the price per unit purchase price. And Q is the ordered quantity. Now we will see what is the appropriate model for deterministic inventory problem with no shortages. Here we see we are getting with the passage of time. We are getting units, and as the time passes, it comes down. That means it's replenishing again at a elapsation of the time. Again, the units are purchased, and it becomes. We can see that this is a zigzag type graph. Now, the number of orders per year, that is D by Q. Average inventory is Q by 2. Ordering cost, that is the number of costs per year into the carrying costs. Order cost, that is CO. And the carrying cost will be Q by 2 into CC. Purchase cost per year is D into P, that is demand into the price. Now, total inventory cost per year is equal to ordering cost plus carrying cost. So what we will be doing, we will be adding these two. Now, at minimum total inventory cost, as we have discussed earlier, ordering cost will be equal to carrying cost. From this, we can find out the value of the quantity required. That is, Q is equal to under root 2 times of D into C naught upon CC. And the total cost will be under root 2D COCC. This is basically used for a numerical problem, and this is the basic theory required, the idea behind inventory control. The problem of EOQ with finite replacement, that is the second case in production. When a company manufactures a component for its main product, its stock model is called a manufacturing model. Throughout the year, the rate of product usage remains consistent. The manufacturing cost per unit is same regardless of the output of the size. Now here, we will denote R as with items desired rate, and K is its production rate per unit of time. D denotes the demand number of units required per year. CO is the setup cost per setup, and CC is the carrying cost per unit time. For economic batch quantity, that is EBQ, here we see that the graph has slightly changed with the passage of time. That time has been broken up into two different times, that is T1 and T2. And the highest point is the rate. During the period T, when the product is produced at the rate of K units per period and consumed at a rate of R units per period. As a result, the inventory is being created at the rate of K minus R units per session. The item is no longer produced during the time interval T2. As a result, the inventory is depleting at a rate of R units per session. Total minimum production inventory cost will be under root 2 times of D C naught CC into 1 minus R by K. That means your economic batch quantity will be under root 2D C naught upon 1 minus R by K times CC. Then comes your deterministic inventory problem with shortages. In this case, the purchase item will be delivered immediately and consumed continuously, regardless of purchase volume. The price per unit remains constant. If no inventory is available when the request is made, it is assumed to be supplied later for a fee. Back ordering is what we call it. This model operation is depicted in the accompanying image. Here we see it's coming down. Here, Q1 is at the top, Q2 is below the line, and the total Q1 plus Q2 is the quantity. The variables which are used in this model are T is the demand per period, CC is the carrying cost per period, C naught is the ordering cost per order, and CS is the shortage cost per unit per period. Then the optimum inventory cost will be under root 2 times D C naught CC times under root CS upon CO plus CS. Now we move to inventory system operations. Let Q star represents the economic order size and T star represents the cycle duration. We will start with demand during lead time, that is DDLT. Stock outs will frequently occur if left the system alone and do not take or make any changes to account for demand or wait time changes. Even if assuming a model with constant requirements and lead times, orders must be made well before the end of the cycles to ensure that the products are delivered exactly at the end of current cycle or the beginning of the next. Now, we allow DDLT to act as the lead time requirement. So DDLT is basically D by demand by per day, and LT is in days. So DDLT will be equal to reorder level, that is ROL. Inventory management system with continuous demand and lead time. The stock level at which one places a reorder decides when to receive the items purchased at the start of the next cycle. If the demand fluctuates, the ROL will be DDLT plus SS, where SS is the safety stock, which functions at a cushion to absorb the demand variation. And K is the standard normal statistic value of a particular service level. Here in this figure, we can see that how different these up and down provides a cushioning effect. Now we move to unit 9, that is aggregate production planning. Aggregate production planning aids in creating, examining, and maintaining manufacturing plans that are needed for continuous and reliable output. Most of the time, aggregate production planning is based on the level of production, inventory management, and forecasted sales during the following 3 to 18 months. What is the purpose of aggregate production planning? The overall plan serves a purpose that is emphasizes a comprehensive course of action that aligns with the business overall strategy and goes without becoming blocked by specifies. Product families are sometimes linked with market segments, or in the case of production plants, to specific manufacturing processes. A furniture company can group its goods or services into a few broad categories, avoiding too much retail at the beginning of the planning process. Popular and valuable measures such as units, rupees, standard hours, or liter should be utilized. Given its worker adaptability, a corporation can aggregate labors in various ways. For instance, if employees at a bicycle company are educated to operate either mountain bikes or road bikes, the administration might regard its workforce as a single aggregate group for planning purposes, even though individual worker skills differ. Alternately, management can aggregate labor along product family lines by dividing employees into groups and allocating a different group for every product. Families production, dedication, line of production, or even entire facilities to individual product families. Now, how this planning structure is, it depends upon strategic decision, that is horizon for 1 to 5 years, design and mixing of the production, location and capacity of the facility. Then comes your aggregate planning, that is for the horizon of 3 to 12 months. That means from months to an year. Here we work on workforce size, shift patterns, and aggregate manufacturing plan over time is planned. The third one is short-term planning. That is planning for 1 to 90 days. That is personal planning, production sequencing and scheduling, and purchase material. The period of time covered by an aggregate plan is the planning horizon. Planning horizon usually is 1 year, but it can vary depending upon the scenario. They typically occur quarterly or monthly to prevent the cost and disruption of frequent changes in output rates and workforce adjustment. What is the concept of aggregate production planning? As this is related to decisions, there are basically three types of decisions. So we will start with long-term decisions. The organization's size constitutes one of the variable influencing aggregate production planning. This will determine the length of the long-term decision using the aggregate production planning idea. Continuous aggregate production planning typically ranges from 2 to 10 years. These decisions refer to product and service selection and encompasses all production phases. Product, market, financial, and resource planning are the part of long-range aggregate production planning. Resource planning determines the infrastructure and employees required to meet long-term manufacturing goals. Then comes your intermediate decision making. Intermediate choice regarding planning have an impact on company's workforce level. Specifically, the organization will analyze the staff's output capability through intermediate average production planning. Intermediate aggregate production planning encompasses many other parts of the business, such as production planning and setting requirements for output. In addition, intermediate aggregate production planning examines the main items group and calculates the labor hours required to make the product groups. Intermediate aggregate production planning often considers time periods ranging from 12 to 18 months. Then comes short-term decisions. After making long-term and intermediate ought to create its short-term aggregate plan. Material planning, capacity requirement planning, final assembly planning, and production activities. Management are all examples of immediate aggregate production planning choices. Short-term choices assist the organizations in ensuring that the final product is made as satisfy the expected goals of the intermediate and long-term aggregate plans. What is the importance of Action planning. Aggregate production planning assists in achieving equilibrium among companies' operational goals, financial objectives, and general goals. It acts as an interface for capacity and demand planning. When demand does not equal to capacity, an organization might try to reconcile the two through pricing, advertising, management of orders, and because you have to survive in the business. If capacity does not equal demand, an organization might strive to balance the two using multiple options such as laying off, hiring excess, inadequate workers till demand decreases or increases. Including overtime as a part of schedule creates additional capacity, and employing temporary staff or contracting out an operations to a subcontractor. The critical points are obtaining financial objectives via lowering all variable expenses and boosting the bottom line. The utilization of general manufacturing facilities to the greatest extent possible and provide customer delight by matching demand and lowering client waiting time. Minimize the amount of stock, expenditure, and the ability to fulfill schedule objectives by fulfilled stuff. What are the objectives and approaches of aggregate production planning? Aggregate production planning primarily objective is to maximize manufacturing while lowering operating expenses. It is an excellent opportunity for the company to cut expenses because the APP enables aggregation across several items and it is called an aggregate. Minimize inventory investment. Through material resource planning, APP software possible balance between of inventory management and storage costs and effort to guarantee enough inventory on hands to satisfy independent and dependent requests. Maximize production rates while minimizing fluctuation. Aggregate production planning software compares production capacity to demand estimates to maximize the total production rate while preventing idle times. And then comes your minimized workforce demand and fluctuation. A workforce plan that balances the cost of hiring new employees or laying them off due to workforce fluctuation with the cost of and overtime is calculated using data from demand predictions and material resource planning using aggregate production planning software. Then comes maximize facility and production equipment utilization. This software production planning targets maximum utilization across the aggregate production planning period, while taking into consideration the manufacturing facilities and the equipments that are already available. What are the aggregate production planning processes and variables? We will start with forecasting. The overall plan is predicting on meeting predicted intermediate term requirements, which is precise projection of these expectations are required. because seasonal patterns are usually essential in collaborative planning. Seasonal time series models are often used to create these predictions. Then comes identifying the variables in planning. The quantity of aggregate product to create during each time period and the amount of direct labor required are almost the same. Visible aggregate production planning factors. The quantity of merchandise to add or to remove from stock and the amount reduced in each period are two different indirect variables that naturally results from planning these other amounts. Overtime employment, outsourcing with another company, or shifting manufacturing to a different site inside the organs are also options for the businesses. Here, we can see what are the different inputs and outputs of EPP. We are talking about aggregate production planning. Now you can see that there are some arrows which are moving towards aggregate production planning, and there are some arrows which are moving from aggregate production planning. That means that are the results. If we talk about what we are getting into aggregate production planning is your capacity constraints, strategic objectives, company policies, demand forecasts, financial constraints. This is the input and what we are getting after evaluating aggregate production planning. That is the size of the workforce required, what will be the production per unit month, production per month, that is what we will be earning, inventory levels, and units or rupees subcontracted, back ordered or lost. This is study of ABB process. What are the techniques of aggregate production planning? Aggregate production planning is carried out using a variety of ways: informal trial and error procedures and mathematical techniques are the two main groups. In reality, less formal methods are more frequently employed. Although there have been much study on mathematical procedures, but they still need to be more widely applied. Now we see how this APP approach is all about. It is related to production planning environment. Production planning has to be done. That means it includes what? Our internal resources are competition, raw material supply, demand, external capacity, workforce, your demand, economic conditions, production, inventory. And after this conversion, the analysis, we get the external output. The general approach for aggregate production planning consists of the following steps. For each period, determine the demand, and for each period, determine the capacity, which includes regular time, overtime, contracting. Determine relevant company or departmental policies, that is, maintaining a safety stock of 5% of demand and a reasonable stable workforce. Establish unit cost for the regular workday, overtime, subcontracting, holding cost, holding inventory, back orders, layoffs, and other pertinent expenses. Create backup plans and determine the cost of each task. If we pick up one that's best satisfied the goals, if good plan shows up. If not, we have to go back to step number 5 to execute it. Here we see what APP process is. We prepare a prospective plan for planning horizons. We know, is the plan acceptable? If yes, then identify alternatives, constraints, and cost. Move further, prepare pre-strict plan for planning horizons, and determine the requirements for planning horizon. If the plan is not at- acceptable, then we have to go back. We have to identify alternatives, constraints, and cost. Again, this process needs to be applied. Aggregate production planning strategies. There are three aggregate planning strategies available for organizations to choose from. The first one is chase strategy. Second one is level strategy. The third one is hybrid strategy. We will start with chase strategy. Here, this is a one-way organizations employ to keep inventory levels stable while creating varying rates to meet demand. As the chase strategy varies production to meet demand, it is also known as demand matching. The chase strategy entails matching demand and capacity on a period by period basis. This could lead to significant hiring, firing, and laying off of staff, insecure and disgruntled employees, increased inventory carrying costs, labor union issues, and unpredictable utilization of equipment and facilities. We can see how, when a graph is drawn with unit and time, we can see that the dark curve is for the demand. With these constraints, the production is shown by dotted line. That means it is somewhat down. This is the chase strategy. In second one, that is level strategy. This establishes an aggregate plan that maintains a consistent production and employment pace. To meet alterations to client demand, the company must raise or lower inventory levels in anticipation of higher or reduced predicted demands. The company keeps a consistent workforce and production rate when demand is relatively low. This enables the company to maintain higher inventory levels than are now required. As demand rises, the company can maintain a consistent production rate or consistent staffing level while allowing the inventory surplus to absorb the additional demand. Here we see that this is a sinusoidal curve. The demand, it is divided into 2 parts, the minus one and the plus one. And your dotted line is the production, and your demand is a sinusoidal curve. The level approach enables a company to keep up an even amount of output while continuing to satisfy demand. It is preferable in terms of employee relations. The expenses of surplus inventory, subcontracting, or overtime costs and backorder costs, often the cost of speeding orders and the loss of consumer kindness were all adverse effect of the level strategy. Then comes your hybrid strategy. Hybrid strategy includes parts of chase and level strategies and are frequently one of a company's most successful and efficient strategies. A hybrid strategy seeks to strike the equilibrium between adaptability and stability. A hybrid aggregate plan, for instance, would feature few layoffs and a generally stable number of inventories. Many businesses choose hybrid plan since they are the most cost effective of the three planning options. The hybrid approach, as its title suggests, combines two levels, the chase method to achieve an improved outcome. It it strikes an appropriate equilibrium among stock levels, recruitment, dismissal, and the manufacturing rate. The managerial importance of aggregate production plans. Most organizations require employees to work longer than usual at short periods of intense demand, typically in exchange of wage increase. This element may be incorporated into a linear programming model by including parameters permitting and monitoring working overtime. Typically, the functions of objective cost parameters for this task is higher than those of the regular time labor. Employing new personnel can sometimes add a whole shift. For example, selecting whether and when to add or to reduce shifts at their production site is critical to the big automakers' overall strategies. Now we move to Unit 10, that is Material Requirements Planning, what we in short call it as MRP. Managing material in the industry are also so essential that the non-availability of required material leads to several problems such as stoppage of production, loss of reputation due to not meeting the demand, loss of worker efficiency, etc. A sound and well-coordinated materials management system is required to avoid this and to ensure a smooth production. MRP is a tool that integrates all the units connected to materials. Material requirement planning is a management tool to ensure that materials and components or the parts are available at the right time to complete the finished products according to the master production schedules. What are the objectives of MRP? It helps to rationalize the cost of excessive inventory, facilitates lead time reduction. It ensures that raw materials and finished goods are readily available for customer production and delivery. It maintains the lower level of raw material and finished products in stock. What is the definition of MRP? According to American Production and Inventory Control Society, what we call it as APICS, MRP constitutes a set of techniques that use the bill of material, that is BOM, inventory data, and master production schedule, that is MPS, to calculate the requirement of materials for making a good line of balance, that is LOP. Material Requirement Planning System schedules and plans the time-phased material requirements for industrial processes. Despite being easy to comprehend, MRP can be utilized in two distinct manners, that is MRP1 and MRP2, that is manufacturing resource planning. First one is material requirement planning. Now we will see what this MRP1 is. The inventory control system promptly issues manufacturing and purchase orders to support the master schedule and effectively handles raw materials and work in process files. This system places order from the MRP1 capacity planning is not included. From this point forward, the term MRP1 and MRP will be used interchangeably. What is MRP2? Is an information system that industrial businesses use to plan, manage capacity, and keep track of inventories. MRP2 system employs a focused production plan to integrate sales, purchasing, manufacturing, finance, and engineering duties. A single database is used to plan and maintain all these actions. Material requirement planning is a scheduling technique for industrial subsystems with numerous production levels. Using the information on production requirements of multiple finished goods in the system, the structure of the production system, current inventories for each operation, and the lot sizing of each operation has to be studied. MRP generates a schedule for operations and purchase raw materials. It is a simple system for figuring out quantitatively how much input material is required at different points, dependent on production plan or schedule for the finished goods. The production and acquisition of dependent demand items are planned to use the MRP computer-based information system. It generates cost-effective production and purchasing schedules by utilizing information on end product demand, product structure and component requirements, production and purchase lead times, and current inventory levels. Planning and scheduling for phased material requirements are done by MRP system production processes. What is the process of MRP? Master production schedule procedure reinforces the independent demands of forecasts and customer orders to determine the finished products requirement in each time bucket. Next, after meeting the on-hand and order inventory and offsetting the lead time, the production schedule of the end product is determined. Further, the available to promise, that is ATP, is also determined. Now, MPS is fed into the MRP procedures to determine the lower level components, requirements, and raw materials. The parts gross requirement, that is TR, are estimated by determining the planned order release, that is POR, through a single level bomb explosion. After considering a lot size, the net requirements are converted into planned order receipts. Lead time. Offsetting shifts the planned order receipt backward and derives the POR, which is the MRP result of the current item. The MRP procedure moves forward to explode the planned order release to obtain the gross requirement of its components. The MRP procedure is repeated until the POR of all the items is determined. Now, MRP throughout all the disciplines of management. In accounting, it coordinates the payment to suppliers and customer billings with the material requirement plan. In finance, it plans for sufficient working capital to back the schedules produced in the material requirement plan. In terms of HR, it assesses the impact of materials plan on personal demands. In marketing, it makes reliable delivery commitments to the customers. Management information systems, it needs to recognize the information needs of managers and the data that can be delivered from the material requirement plan. Now, how this MR generally, raw material purchase according to the final good demand is instantaneously updated within the system's product in an item-focused structure. Because of its complicated storage and manufacturing plan, MRP provides significant advantages to process-focused items or systems with prolonged processing durations and interactive multi-stage production stages. The initial components would be ordered to meet finished goods specifications precisely. Process focused systems have internal processing lead times longer than the lead time requirement to receive raw material from vendors. The ability of MRP to account for longer lead times and interactive manufacturing process is scheduled order receipts considerably facilitates manufacturing and stock planning. MRP is often used in industrial systems. Many people contend that MRP may be effectively employed in non-manufacturing systems. MRP can be used when service systems require groups of raw materials to provide a single unit service. Surgical procedures at big hospitals, large quantities of professional services, and other procedures are expected to employ MRP system. Implementing an MRP system is a complex. What are the inputs and outputs of MRP? The Master Material Requirement Plan aggregates requirement for all items and the subsequent reports and documentation produced by using this plan. The calculations that MRP performs are based on the data inputs. Input for MRP are master production schedules, bill of materials, and inventory records. And what are the outputs of MRP? That is the purchase orders, material plans, work orders, and the different reports pertaining to them. Here we see inputs are work orders, MPS, forecast, inventory. In MRP process, explosion, netting, offsetting, lot sizing, all is performed. And what we get in the output. Output is related to purchase orders, material plans, work orders, and the reports. What's master production schedule? It is a strategy for producing each period commodities, such as for manufacturing, recruiting, inventory, etc. It is typically associated with manufacturing, where the plan satisfies when and how much of every goods will be required. Before the MRP system operates, the MPS is created using customers' order from the company or demand predictions. The MPS was created to satisfy customers' demand. As a result, it specifies how much of each final product will be produced over each subsequent time in the production planning horizon. The customer service component is also put up in the MPS as an end item. The MRP system receives its primary information from the MPS, and the MPS controls the MRP system's suggested actions regarding the material acquisition and subcomponent production timing. The goal is to determine the outcome of the operations function by utilizing the master schedule to regulate customer service, inventory levels, and manufacturing expenses, thus allowing top management to exert control. Top managers cannot complete the master scheduling work independently due to the excessive complexity. They can control the materials planning process by setting master scheduling policies. Top management should connect with the industrial sector through the overall product strategy. The comprehensive manufacturing plan considers product families or product lines rather than concentrating on particular goods or models. What is bill of materials? Well, an organized inventory of all the parts of materials required to manufacture a specific finished product's assembly Subassembly, purchase domain, or manufacturing part is a bill of material. Certain businesses may use multiple BOMs for the same item. There is only one BOM in engineering, but manufacturing and cost accounting variations exist. In the MRP system, a unified bill of material has been implemented across the entire organization. As product undergoes redesign, BOMs are continuously evolving. Error in the BOM prevents the necessary materials from being ordered, which prevents the production from being assembled and sent. Consequently, the parts already ordered and in stock will be put on hold while the missing components are rushed to complete the inventory. All ROMs must meet strict accuracy requirements set up by the management. Having high or great precision comes to at a minimum cost. Instead, it is too expensive to expect BOMs with flaws. All items records of product construction is given, including all the informations for assembly, along with the required quantity and the work centers responsible for each phase. The BOM describes each subcomponent item, where it goes to each finished unit, how much there is, and how they are created. With this, we will be concluding today's session.